Hello, hello, hello. Today I'm tackling quest 17 of Everybody Codes. Got my template ready, Wallopy is spinning, test ready to a go. Here goes nothing. Boom. So we got a map, a grid, a whole universe to play with. Cool. And stars? Ooh, a constellation. Okay, what's the size of the constellation created from the stars in your sky? In this case, it's 16. Okay. So star coordinate, star coordinate. So I can find the stars. What am I supposed to do with them? Create a constellation from this group. The sum... lowest possible size. Lowest possible size. Okay, so like instead of having a line from here to here and from here to here, create okay, so this is a graph problem. It's a tree. It's a spanning problem. I don't think I need to do that too badly yet. I can just go for it, and I forget there's like 3 algorithms that do this in different ways. First thing we need to do is get a world. So world equals notes split line, map line, line as an array. Then I need to get all the stars. And basically, I think I need to create edges from every star to every other star, and I can pass that thing to another algorithm. Const stars equals an empty array for 0 r world length r plus plus. Do the same thing for columns, except it's this, so we're handling rectangular universes. And then it'll be if world rc equals star stars, nope, stars, come on, stars push RC, you know what? Let's keep it stars, but these are really our nodes. Const edges equals, I don't know if I just create an array of objects or did I make a mapping thing from star to coordinate. I don't know. I need to figure out the algorithm for this is. Minimum. Oh, here's some stuff. Prim's algorithm, Kruskal's algorithm. What's the difference? I don't really remember these. Ooh, great visual. Okay, let's see what I want. So it's joining together the least edgiest edges. I don't like that. Start arbitrarily and then choose the one with the lowest weight. This one is more logical to me. I'm gonna go with this one. So we're going with prims, which means we need to have from here to anywhere else. So I need the graphy graph. So const graph equals here. So from a star to every other star. Here we go. So for const from of stars. For const 2 of stars. Now if they're the same, then that's where we fail out. If from equals 2, continue, can't go to yourself. Then the weights will be the distances, which, yeah, I don't think we need this anymore. I can figure the rest out. Are we doing Manhattan? Okay, so they're actually giving us things, so we can validate that. 1 and 3, 2 and 3. Yeah, I'll figure that out later. So we want to say, I guess the stars have IDs. So ID, nope. They're going to be the order in which they're discovered. Let's actually go for what they're putting. +1, right? So 1, 5, 1, 2, 3, 4, 5. Oh, this is the exact order I'm doing it. Man, I like this, I like this. Okay. So if from ID equals 2, ID, continue. Otherwise, we're doing cool stuff. And that cool stuff is saying const from map equals graph from .id, if not from .id, and graph from ID is, ta-da, we did it. We did the thing. We have access to the thing. I think I just need to put in from map, then 2, which will be 2.id equals distance between from and to. So I'll figure that function out in a moment. I think that moment is right now. Distance between from to, I'm trying to think what it is. Math.abs from r minus 2r, and I think you add these together, plus math abs from c minus 2. We'll see what these distances are. Graph, what do we got? Okay, so from 1 and 3 is a distance of 3. Well, 1 and 3 is a distance of 3. How about 4 and 5? Distance of 2. 4 and 5, distance of 2. Okay, this seems to be a bunch of 3s and 2s. 4 to 8 is a distance. Okay, so we're not looking at that. I think it's showing us the ones that they decided to make, which were the shortest. So I'm trying to think, if I did the Krugels one, it would generate this one, this one, this one, and then this one. If I do prims, I think arbitrarily wherever we start. I'm trying to think of a bad reason not to use prims. If I start here, I'll generate this one, this one, this one, and this one. Yeah, I think that's fine. And you know what? Let me try and find. Nope, not that. Prims algo. Yeah, I mean, I could reinvent it, but why would I do that when I already. JavaScript, hey, okay. Oh boy. Ooh, I've made an adjacency graph, or whatever this is. So this is from 0 to 0 is 0. Okay, I see what they did here. I can turn my thing into a thing to print MST, to just do the thing, a utility function. Okay, so I guess we need all of this. I don't like it, but we will survive. Yeah, we're not going to print the MST number of vertices, so that is just weird. The heck? Okay, I haven't actually used prims in a really long time. Min key. I think this is the one thing I just really need to implement, right? So just find the one with the shortest distance that's in my thing. Yeah, I think I can do this. String to record, string number. Boop, yep, that's what I have. We're going to do the exact same thing here. Okay, so it's going to be basically, I'm going to start arbitrarily at the first one. So cost connected equals object.keys graph is 0. Let me go look at this code, 'cause I think there are bits there. I feel like there's something here that I'm not aware of. Can I just read the description? Maybe that'll help me. How to implement, keep track of vertices. Distance to vertice is infinite when you don't have all of them. Pick one that's not in there and has the minimum, include it. Update the key of all adjacent vertices. I don't see what this is doing again. I don't know if I need that. I'm just gonna go for it. So connected, so while not connected length triple equals keys graph length while they're all not connected. Then we should need to keep doing some stuff. So that is going through all of them and finding the least edge. So next edges, I think this is the universe in which some of them are, what do you call it, equal, right? I don't know if I'm just gonna, I feel like just going for it, honestly. Yeah, I'm just gonna take it. I'll take this as is. I'll fix it in a moment. Okay, so instead of v equals 5 equals, what the heck is this doing? It's the min set. None of this has types in it. Okay, so we have graph, which is, well, one number array. I'll build that. Graph dot length, right? It's that many. Sure, it's a little better. What's this other thing? We have graph here, but that's, yeah, that is graph, so that is number. Therefore, I can use graph dot length parent, which is number, I guess. I don't know, these all really make sense. I have not done this in a hot moment. Return graph or print MST. Heck is this even printing? So it's going through the graph. So we're building a graph? What the heck? That looks weird, but I'm gonna go with it. So I just need to call this with a good graph. So const graph equals an array. So same thing, I just need to build it differently. So for from const array equals this. And we do conclude ourself. So distance between from and to, instead of we do this, we say array.push, distance between, then we'll adg graph.push array. Let's see if we did that. Do the O's, yep, they do end up and they are mirrored across the thing, because that's how that would work. Okay, I think I have it. Now I just get to call it and hope all this code I stole works. Don't really know what I'm looking for here. I mean, I know what I wanted to look for. I don't know what this is going to give me. V is not defined. Where did I miss it? V is not defined. Oh, okay, model format. I love that. Oh, hey, this is wrong. Oh, sure. So you get to pass it a V. Now I'll have to pass you a V, which is graph.length. We good? We're not good. Why? I'm expecting to see some logs here. Right, okay, so we're seeing 21024324. Is that... Okay, it's giving me connections, I guess. Sure. It's doing this weird parent thing. So we have things and we have the ones we're going to. What do I need is I need all the distances. So I need these values. Which is what I can return all the way up the chain. Three, 3, 2. I mean, it still does the same thing. Turn, reduce, A plus B, start at 0. Watch out for the crazies. Expected 11 to be 16. Huh. Wait a minute. And the sum of all connections is 11? Oh, so I have to do this plus radius.length. 15 to 16. Contains 5 stars. Well, that's just the graph length. Well, it's adjacency graph length. I don't like this, because I feel like... Well, first I just don't like this prems I found. 135. I'll take it. But I don't like it. Okay, I'll take it. The size, bigger, bigger, go bigger. Okay, so I'm just gonna go up and clean up that log we got up here. That was it. That was all I think I needed to be bigger. Don't have an example. It's just bigger. So shove that in there. Drop part 2 from there. See what output we have here. No, come on, give me fail reason. Give me. Hey. Why have you failed? Wallaby. Part 2 notes expected. Hey, look, it's a number, finally. I don't know if this is gonna work. I feel like I'm doing some things wrong. Nope, it's good. Distance between connected stars must be less than 6 if 2 stars or group are far apart. Okay, great, we have an example. Number, big number. Okay, let me read it. There are 4 brilliant constellations. Why? Must be less than 6. If 2 stars or groups are further apart, they are considered as separate brilliant constellations. Identify the 3 largest brilliant constellations and multiply their sizes to get the final answers. Okay. The distance between must be less than 6. Okay, so basically, hey, if the distance between me and my friend are more than 6, you're not allowed to connect. Okay, can I do some pre-processing to basically split this? Group by things that are less than 6 to one of their siblings. Or to their siblings. Yeah, okay, it's going to be tough. This also could just be a modification of prims. 3 largest. Okay, that's an optimization there, but I'm not going to go for it. So the thing is, prims connects all of them, unfortunately. Yeah, it basically goes through all of them. So I want to try as many as possible. And then the ones that aren't connected, y'all suck. Okay, let me... Why is this failing? I don't know. Oh, have a filter on. Short, big fan. Let's focus on our new one. Picture 108 to be... Yeah, you connected literally everything. Bad. Very bad. So how do I break this up? So I can just start grouping them by if them and their friends are less than or equal to 6 to anyone. That's going to be an expensive one, but I think that'll work. Yeah, I think I'm willing to take on the expense of that. What? Is that a duck? It's the duck. Hey. There's also this really weird big constellation. Okay, it's gonna be expensive, but I think it'll work. Hopefully it scales good. Yeah, I think this is part 3 now because we're doing some stuff. Yeah, we have stars, we have the graph. We don't really want the graph. We do. We want to group them into ones that are subgraphs. So I guess groups cost graphs, I guess, actually. Right? And then I want to add one. So I guess, yeah, there's going to be an empty graph here. Well, there won't be any graph here, right? So we find one and we go through all of the ones in our current graph, see if you're less than or equal to 6. If you are, congratulations, you join that one. Otherwise, you join a different one. Let's do this. So I think it's all of this one. Yeah, so we're trying to add this star. And we're going to see if you belong to any of the graphs. Const existing graph equals graphs, find G. And I have all the associations here, which are great. But I just want to look at the graph. Okay, let's rename this better. So constellations. Existing const. So constellation will think of two things. C dot stars find has star distance between from star less than or equal to 6. I need to, dang, I typed start again. I need to look back at this. Must be less than 6. Less than 6. Less than 6. There we go. So we find a constellation that has that. If, let's put a let on this. Not existing const, congratulations, you just got a new one. So const push. Let's multi-line this. Not extra inline dependencies. Existing const equals stars, congratulations, from graph, and then sure, we'll do from .id to no one because we have no other stars to go to. Great, so that's building these up, and then we'll do this looping down here for fun stuff. So boom, we have a constellation. You're cool now. What we want to do, and I might as well. Oh, that's illegal. Oh, I forgot. All right, so we have a constellation. Now let's empty it. All right, let's not put a graph on there, right? We just want to join you to your existing constellations. If there isn't one, push it otherwise, no matter which way. Stars.push from. Right, so we have our constellations, so our const. So for constellation of const. Then we build the graph and we'll attach it to each of them. And technically we just need the adjacency graph. Drop that from map, we're not using that. So constal, then adjacency graph. Again, we're eating up all the memory here. Constal graph, adjacency graph. Boop, there we go, we have all the things. And it's not for from of stars, it's constellation. There we go, we only go over the ones we care about. And then, this is for each of them, we do this. What's the math down here? Sizes. Okay, wait a minute, just sizes or to do the other math with it? Final size is that. Okay, so it is sizing. So const size equals size. Great, look at all these things we're adding to our constellations. Okay, then we have a bunch of constellations. We just need the top 3. So return constels or const.sort, not sum, sort a dot size minus b dot size. Let's think. I want smallest. Is it largest? I want the 3 largest. So it's b to a, and then it's slice 0 to 3 maybe. A plus b, start at 0. We're adding b dot size. So that slice may be wrong. All this other stuff might be wrong. Lots of things that might be wrong, but let's find out. That's our notes. We're not running that yet. We're running our test case. Expected 108. It would help if I called the new function. Oh, has no is not a thing, right? It's sum. Where's the code it's angry at? There we go. Awesome. Star is blah 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 blah. So it's either working. Expected number to be number. It ain't working. Okay, so I just need to see what these I got looking around. 1, 2, 3, 4. So I have 4 of them. 1, 2, 3, 4. Sizes 14, 21, 24, 21. 14, 21, 24, 30. Oh, this is working. Multiply, but I was adding. Yeah. Okay, so that's running. Now it's running on a focus. Where is my life? Here is my life. Here comes where everything goes on fire. So let's put the dot only here. Remove this from filter, and let's watch my computer eat itself alive. Oh. Okay, Wallaby, please show results. Part 3 notes. Expected big number to be other number. No. Answer length, but the value is wrong. Okay. Oh, that's concerning. Hold on, there are 2 numbers here. Okay, I did put the right one in. Yeah, there's no space there. I got rid of it. Good me. So it's not this. Interesting. So the thing is, maybe it's less than or equal to 6? I don't know. Let's wake this back up. Let this run. My slice could also be... No, it's working in the example. Where am I doing the distance between bit? Less than or equal to 6. How about that? No, the example don't like that one now. It's smushing them all together. It's doing some bad stuff. Okay, this is interesting. What distance calculation am I supposed to be using? Manhattan distance JS. Let me... Oh, hold on. Apologies, OBS being a thing. I think I stole this from somewhere else and it worked well, but it's basically math abs 0.1 minus 0.2. I just absolute the things together and it works beautifully. Interesting. Okay, let me reread 3. Three largest brilliant constellations and multiply their sizes. So I can start logging some things. So let me just look at this. We got the 3 biggest, and then we got a lot of 1s. Interesting. The repetition is concerning. So I could do some splattering here. It's gonna be a long input slash output. I have all of them, so I can just redraw the world. Yeah, let's do that, and then we'll target the top 3 and do all that. So for const C of const dot entries. Here we go. We're gonna say for const s of constal stars. We're just gonna say, hey world RC equals I'm trying to think of the math now. Car code at trying to think of this. You know, I think a number would actually suffice. Car code at 0, 0 plus. See, this is eventually gonna be bad though. And yeah, I know it's s.r, s.c. It's not assignable to string. Be quiet, you. From car code, right? So I'll just do this. It's gonna run out after like 26. How many constellations do I got? 200 in this one. Okay, so after 26 we start going weird characters. Let's do this. 26 if greater than or equal to c equals, turn you back into a star, right? So the 27th one we can't do. Great, now let's look at the world, or write to the world. Alright, file sync. Let's comment this out because REPL's gonna do stuff. Map txt world.join world.map l.join empty, and then each of these .join a new line. Yeah, I think that'll work. Let's see what happens. I don't know where this file is going to end up. Oh, I've goofed all my symbols. Much apologies. Oh, nope, I missed that symbol, Boom, map.text. Oh, it's doing, hey, you're doing the thing. Hey, don't do that. I just need to focus on, let's focus on the one that we can probably solve, right? Let's see if this visualization is a good thing. Hey, what part of focus on the one you're not doing? Do I have a dot only here? I do. Okay, fine. Let's move it down to there. There we go. Look at the map. Be like, hey, look at this. It's A, B, C, D. I don't know why you chose that order. So I would have thought top left, bottom right. Oh, you're sorting by largest to smallest. Okay, you're literally doing what I asked for. I win the problem. Yes, let's move this only to here. And look at our mippity map. Okay, I'm already seeing, the heck is this? The heck are y'all doing here? This is wrong. Y'all are part of the same constant frequentation. That shouldn't be possible. And then we find all the ducks, sure. Yeah, the constellations are not finding each other during construction. Do I need to do another thing where I'm like, hey, y'all found a constellation, nearby ones emerge? Is that what I need to do? Because, I mean, just looking over here, this is wrong. And if I look at the original map, let me see. Yeah, this is top left, like 15. 15. Yeah, it's these clump right here. L and then dot and 2. L and then dot and 2. Yeah, this. Don't know why they're not joining up together. Why don't they want to be friends? So I'm going to drop this one here because I see the problem. I'm only seeing it in the real problem, so maybe I'll go back actually. Yeah, I'm not going to see it solved elsewhere. Okay, so our constellation finding each other this is basically this. Any star, distance between me and that star, less than or equals 6. Let's see, you found A, you found D. That's what happened. You eventually get close, but then you never rejoin back up. Okay, so maybe just that thing that I said, constellation merger, would be the move. For const C1 of consts, for const C2 of consts. Basically, if you're the same, then we merge it together. Const new. Sure, and then it's basically if any of y'all are within 6 of each other. Oh, Wallaby, I forgot you're still going. Hey, let's not run my computer off the wall. Big thanks. If any C1 stars are within 6 of any C2 stars, merge both. So if C1 stars some C1S and C2 stars some C2S, distance between C1S, C2S, less than 6? This feels really wrong. I mean, they are using some, so we're going to get some short circuiting here, thankfully. Right. The thing is, as this goes on, the merge is... this is tough. This needs to be index-based to allow merged ones to remerge with new nibbling, sibling ones. So this needs to be a for loop for let C1 equals constant length minus 1, C1 less than or equal, greater than or equals 0, C minus minus. Right, so we just need to do this for both. I think you go inside. We'll just keep you offset by 1. I mean, if you do both end up the same one, we're just going to ignore you. Now we just need this bit in here. C1, so it's const C1. And then const C2. Right, and that'll basically be, hey, y'all merge together. Now, which one you merge under doesn't really matter, kinda, really. And when you merge, I'll need to get rid of one of y'all from the big array. I just realized I put all these here. So I think you start from C1 minus 1, buddy. You're never gonna be on me. And if this one's... because I need to create space for both pointers to exist. It's a backwards one, which has me doing the math literally backwards, which is not good for my brain. Great, so they're both the same. Because C1's on the right, C2's on the left. That means C1 goes away. So, const C2 dot push const C1 dot stars. Congratulations, y'all just merge. Const plus C1 1. Great, so we did that. We kind of need to break to allow this to stop, because C1 is now pointing at something wrong. Right, they got merged, but that merging technically is just a deletion from this. I could have done this much easier if I would have just been like, keep trying to merge until y'all can't merge anymore, but I've written it this way, so yay. Okay, let's get this cooking back up again. Const C2 push. Yeah, that's not where you push stars into. It's a little better. Not happy though, unfortunately. Well, it's not happy because we don't know the answer. I need to... There's no harm in putting this here. Let me look at the map. Oh, I'm liking this. This is a good looking map. Let me look at the duck. Where'd the duck go? Here's the duck. Oh, that's a ducky looking duck. Yeah, you're connecting to all your things. Let's hit it. Boom. Woo, we got it. Okay, that was a really fun one. Let me put my right answers. We'll walk through it, and then we will refactor away. Yep, that's the right answer there. Let me drop my onlys. Gotta get part 2's right answer. And I think part 1's answer. Yeah, I never put that in. Grab that. Okay, we should have everything. Well, he's gonna run everything and write a freaking map, which is what we don't want to do at the moment. We'll leave that here because that was a good debugging step. Boom, all passed. Let's drop some logs. Boom, I am loving it. We never wrote this. Okay, let's commit this. Initial 17 solution in the bank. Okay, let us walk through the challenge. So, oh, did they literally give us the algorithm for distance? And they said it was Manhattan? Wow, okay. I should have read more, but that's okay. I figured it out within a short period of time. So you're given a world with asterisks. These represent stars in a coordinate 2D grid. They numbered them like this in the order of discovery, top left to bottom right. That makes things easy when referencing. The coordinates are row, column. They use 1 offsets. Well, they do bottom left 1, 1. Yeah, their system is cool and all that there really to visualize. So when they create a constellation, which is a minimum spanning tree or whatever, between these, it is the smallest possible, which is calculated by how many they are and the lengths of the edges. So instead of like these 2 stars both connecting independently to the center one, creating a length of 4 and like 4 point something or 3 point something, we create a length of 1 and then a length of 4 for a total of 5. So that's kind of the goal, to get the smallest constellation possible given all these stars positions, which is a minimum spanning tree, kind of textbook definition. They also give you the distances for you to verify against. Once you get that, you output the size, which is how many stars and total distances. Part 2 is, hey, did you use an inefficient algorithm? If so, you busted. Part 3 is effectively, there are multiple constellations. If a group of stars is 6 or greater far away from another group of stars, they are considered a different constellation. So these are 4 different constellations because their closest stars are further than 6 away. So the answer to this is find the largest 3, multiply their sizes, and that's your answer. Yeah, that is the challenge. Let's get on to the refactoring. I'm going to leave the refactoring of prims to the end because honestly I could write it in a style I would prefer, like using my object-based graph instead of the adjacency graph, but that's not the interesting part of these. I believe you can go on YouTube and find 500 videos on Prim's algorithm. So we have the main solve, then we have solve 3, which is really the main solve, but with the 6's in betweens. I wonder if we can use that for the 1's and the 2's. No, they have a distance of greater than 6. So I think it would be a conditional of like, hey, how close can these be apart? So I'm going to do that for this. It is going to be more computational because we're doing a bunch of checks. And this constellation gatherer definitely could do better. I don't know what the better is. I might not even get to it because I don't know what it is, but having to merge the groups together. Not fun. Okay, let's start with the easy part though. Stars. Yeah, I think that's literally all we really care about for the first thing. So const parse stars equals notes string, and then a lock, which I'm gonna type, equals r number c number. Array of locations. So let's do this. We're not jumping anywhere. I keep typing the word starts. I don't know. I just really want to start something, you know? Can I say? Yeah, we don't need to type this. Oh, they also have IDs. What do you know? So yeah, we're just gonna call you star. That makes more sense. Boom, we have this, we have stars, we have that. We have distance between, which is just, hey, you can figure that out. Yeah, that's relatively straightforward. And then let's make this a parameter. What do you want to say? Constellation distances. Constellation. So here y'all gonna figure out why I kept on abbreviating it, both for speed and I don't spell constellation on a freaking daily. Distances. Number equals 6. Boom, we'll go with 6. Yeah, we'll just keep using that for there. I think that's the only 6 I have. Nice. Oh, I needed this for mapping. We're not gonna keep this around. Ooh, so this is a temptation. Another one. Do I begin the great visualization? A real visualization. I'd want the lines, not just the characters just popping into existence. So no. So I'm not doing that. Oh, this is also doing the thing of doing the multiplication, doing all that. Okay, yeah, so my generic will need to be a bit harder. Yeah, so let's function get const. Here we go again. Constellation sizes. And then this takes notes string, constellation distances, boop, boop. And it's basically this entire code minus the last line. Now we're going to sort them, sure. And you know what? We can actually go better. Let's just give them all the sizes and let them decide what to do with it. Yeah. So we can now call this code and this code and then be like, hey, now you can do your slicey, wicey, and all that other stuff. Notes, constellation now. Constellation distances, which at this point, just hard code to 6. You're part 3, you don't need it. Boom, okay, still works. Now I think for part 1, we just call this with a big constellation distance. A bajillion. And we're good. Then we have the size. Which is that. What the heck? Oh yeah, I guess we do have the sizes here, which we calculate and then put on the thing. Okay, I love it. So it's just return notes numbered at max safe integer 0. No. Part 1 example. Expected all this to be 16. Hey, what are you doing? Supposed to be returning my numbers. You're doing other stuff. Oh, you're giving me the constellations. Hey, I love that. It's not what I want you to do. Hey, you know what? Let's just go for the straight map. Then we can just do the straight numbers. That's all we care about. Now my solve 1 will be happier. Okay, yep, they're all happy. Boom, 5 green. Boom, that's what I was looking for. Okay. We just ripped out that code to do that code. Now we can clean up this code, which is group stars into constellations. It's really just get constellation stars. ETEL. Constellations, which I'll figure out what this needs to be. Let's figure out what this needs to be. I think just all the stars. Because this is what this logic is. Boom. There we go, and now I can use the actual word. I know. Constellations. I guess I need constellation distance. Makes sense. That's how you do it. This is where the number actually matters. So we'll keep using the same variable name for ease. Let's get constellations stars, not ST1. Stars, constellation distances. Boom, flat passing, love it. Let's get some naming going on. And then for constellation, there we go. So we build a graph, and then we do nothing with that graph, and we build an adjacency graph. Let's go straight to the adjacency graph. Yeah, go straight to it. You don't need it. You don't even need it saved here, because you use it right there. So, number, boop, 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 boop. Build the array, push the array, and all that fun stuff. Can be optimized since it's double directed? No, it's something like that. You can go both ways. Bi-directed, there we go. Yeah, this is a map. There we go. And then at that point, this is just a map of maps. Let's do it. Constellation stars dot map from boop boop bop bop bop. I don't think I need this typing, do I? Oh, it's taking a moment to do this. I'm a little concerned now. Hey Wallaby, how you doing? You're chugging. I don't think it's the same. Okay, yep, I goofed. Put it back, pretend I didn't do this. Now this looks good here. Please don't kill my computer. Okay, we're good back to here. We'll keep it here for now. We'll go the next level later. And then what do we have? We have edge weights, distances, and we'll keep that kind of vanilla. Add up all the distances. It is the length. Chuck it on the size. Not describe. Boom. So we attach it to the constellation, which honestly, we didn't need to do that. We can just be like, hey, look, we got some sizes here. Let's do that, right? Let's go full functional. Then we're going to do all this funness, but return the size. Then we'll straight sort on that and drop all of this, which means we don't need to shove that in a variable. which means we don't need to put that in a variable. All these variables we hate. Get rid of all of them. They mean nothing to us. You know what? We're gonna go full crazy. One line arrow function. Woo! Readability? Who needs readability? We don't need to read our code. That's someone else's problem. We do. We're just being bad. I would like this to be somewhat readable, so I'm gonna do that. Okay, we have that going on. It's still functional. 5 all passing. Quest 3 is doing that. Where's quest 1? I want to bring you up to the party. Well, it's 1 and 2 technically, but you deserve to be cool. Okay, and then you get the last 3 and you do your thing. Sure thing, buddy. I'll try my adjacency graph build later. This, as gross as it is, isn't the worst. This is pretty bad. That I built constellations, which are just an empty object with stars in it. Yeah, I'm not a fan of this. See some cons. Congratulations, you're on array. Push straight to it. There is no dot stars. It is nothing but stars. Update this also. Oh, I got all of them. Nice. Love that wallaby. Good feedback. Apparently we don't always run this. If it's the same continue, we should run this. Why are you yellow? Not gonna worry too much about it. Existing const. This does still serve a purpose, despite me having to do another one. I'm trying to think really briefly if there's a way I can do this better, because if I look at the map, what happened was it was these two, for example. They eventually became a constellation. So if I look at this one and I'm like, okay, I want to find all things that I ever touch. It goes down this way, and then it joins up with this, which this section were D's. And we can't see the future, right? So I think this is a perfectly fine substitute for now. It does its job. It can do better. This is painful. But I'm trying to think of like, okay, fine, we'll just keep top left, top right, bottom right of the constellation. You can't do that because if something like pokes in polygonally, it's not gonna work. So you just need to keep only the stars that are on the outside edge. That could work. That would make this less painful. So yeah, let's go ahead and generate the algorithm for that, because we're getting really geographical now with like generating from a bunch of points. Let's generate a single polygon that encompasses all of them. Okay, we'll make sure this is good. World, stars, find it, you add it, you have IDs, those are great. I'm not gonna touch this. Prim's algorithm. It's great. I'll get rid of my logs for that. I like this, I like this, I like it. Okay, so that is our refactoring. And now what we will do is we'll go ahead and walk through it. We don't need Manhattan here no more. So, we're going to start off the easiest one. The first one. So we're saying, hey, get me the sizes of all the constellations. And we say that basically any star is part of the constellation, because we're saying the distance has to be at least 2 point something billion in order for them to be different constellations. And they're all pretty close, so that works. And then we just get the size of the first one. That takes us into the party. So first we parse all the stars out from the notes, which is splitting it into a matrix of characters, going through every row, going through every column, using 0 to make sure we handle the rectangular universes, If the current character is an asterisk, then it's a star. We keep its row, we keep its column, and then we kind of do an auto increment ID, which is just the length plus 1. So the first ID is 0 plus 1, 1. Second ID is 2. We didn't really need to do an ID, but it makes it easier to compare against the example, which was my main purpose, and it makes it easier to like log and identify them, like easier than row column, mainly because of their example. ID serves no functional purpose. Then we return the stars. So after we do that, we have amazing stars. We pass it to get constellations, which with the constellation distances starts building them up. First it goes with no constellations, and it's like, hey, are there any stars or are there any constellations? So find the constellation that has at least one star that is close enough to the star I'm looking at, this one, to be considered part of your constellation. It's like, am I cool enough to join your circle of friends? If so, then this is truthy. It will short circuit truthfully, and find will take that boolean and be like, oh, you said true? Great, here's the one you returned true on. If you didn't find one, that means there are no constellations that are close enough for you to be friends with, which either happens because there are no constellations or because you are too far from any constellation to be able to join their stars. Then we'll make a new constellation, and we'll call it an empty array. We'll add it, and then be like, hey, this is the one you're joining. And then you will either join the one you just created, or you'll join the one that you found you were close enough to. That works for most of them, but then there are some constellations that don't initially see each other because they start way far out, but then they do eventually get close to each other. Imagine a V, right? So like the constellation starts in the top left. This one starts in the top right. These two stars are more than 6 apart, so they're not seen. But then as they get closer together, kind of like in the map, they're far apart. They get closer together. It's like, oh, it turns out we were like neighbors all along, but we're technically part of different groups now. So like, what are we gonna do? This is what we're gonna do. We're gonna go through every constellation, and we're just doing this backwards for a loop, so that way we don't have to deal with indexes and things getting weird whenever you're modifying an array you're iterating over. First, try not to do that. But whenever you do have to do it or end up doing it, if you do it in reverse order, the indexes work better as you remove things. Because if you remove things as you're iterating up from 0, then you will skip something unless you explicitly, as you remove something, tell it to decrement your index. It can be done, it's just weird, it's just janky. This turned out to be jankier or more complicated than I would have liked, so I probably would have written it normal loop style going back, but TLDR, we have 2 pointers. We have the one that here and the one that is to the left of it. So this is the right pointer, this is the left pointer. If they're the same, we'll ignore them, stop that. And then you go through this constellation and say, hey, are any of my stars close to your stars? Like, do any of our stars touch? Which is it's a for loop within a for loop, effectively. Thankfully, we are using some, so like those are effectively break statements in those nested for loops, but they're nested for loops. It's gross, it's not very good time complexity. If we do find any of them, like we do eventually have neighbors, then we're going to take all the stars from the first constellation, put them in the second constellation, and delete the first constellation. And after we delete a constellation, let's stop this so that way we don't keep trying to put things in constellation 1 somewhere else when we just deleted constellation 1. Then we return the constellations. So all that just to get the constellations. Next, we're taking a constellation and we're going through all its stars and we're generating an adjacency graph, which, again, not going to go through the basics of something that can be Googled, but It is a two-dimensional matrix that represents the positions, well, the distances between different nodes. So let me see if I can get this to spit out. If we can get this to spit out, I'll look at it. Okay, here we go. So we have rows and columns. So coordinate system. This is 0, 0. The distance from star 0 to star 0 is 0. The distance from star 0 to star 2 is 3. The distance from star 2 to star 0 is 3, which is the exact same 3 that you can see over here. Like if you draw a diagonal line along these zeros, you can see in this particular adjacency graph, they are mirrored. So this 6, you're going to find it over here, because it's the same distance to travel to something as it is to travel from something. That's not true for all graphs, hence this dimensionality is provided. In this case it is, so not the best data structure for the data, but it's the one the algorithm took, so I was like, fine, when in Rome, you speak Roman. Well, that's not the expression, but that's what I decided to do. Pass that to prims. Again, prims does prims. I modified it to return the weights of the edges, which in our story is the distances between the edges. I add them all up together, sum them together, then I add it to the length, which is the algorithm for getting the size of a constellation. I then sort them descendingly, so from largest to smallest, B to A, and then you have them to do what you want with. Part 0, well, part 1 and 2 just want that size, so just give it to them. There's only one constellation. Part 3, of course, is like, hey, there are different constellations in the universe. So the distance between them is 6. It wants the top 3. Remember, it's sorted, so this is the top 3. And then you are to not add them together, to return the product of them. So you multiply them together. Don't forget to set your initial to 1, because multiplying by 0 never going to get you nowhere. And you're done. Bada boom. Bada bang. What did I not do? Oh, I smushed some stuff together. Love it. And with that, that is Everybody Codes Quest 17. It's a pretty fun one. I can see not necessarily being the funnest game, but being a cool one to visualize for sure. With that, I'll see you in the next one. Always a pleasure.